Today we're going to look at some more solving for complex roots, but this time we're going to look at cubics. And whatever we do for cubics, we can also do for quartics, we can do for powers of 5, powers of 6. They all work the same way, but we have to be able to find a certain amount of things along the way. So to start off with, what we're going to do is just deal with cubics, because that's all you'd be expected to do in the exam. You don't have time to do any of the higher ones. We're going to look at this question here, which is x cubed plus 6x squared plus 13 plus 8. And we're trying to find the complex solution. So they've kind of given us a hint already that they're going to be some. So to start off with, what we're going to do is there's going to be 3 roots. It says so here, power of 3. So probably 2 of them, because of the conjugate root theorem, are going to be complex, and one of them is going to be real. So we're going to try and find the real one first. We use the factor theorem to find the real one. So we're going to put in factors of 8. So P of 1, put 1 in, we get, remember it's the front numbers here, so 1 here, 1, 6, 13, it's definitely not equal to 0. If we put negative 1 in, we get negative 1 and negative 13 is negative 14 and positive 14 equals 0. So x plus 1 is a factor. And negative 1 is a root. So if we know that x plus 1 is a factor, we can go through all the others, the 2s, the 4s and the 8s. We won't find any more that are equal to 0 because we kind of know that there's going to be 2 complex ones. So we're going to shortcut after we've found 1, and we're going to divide by it into here and find out what is that quadratic we've got left. So remember, we take the numbers at the front, 1, 6, 13, 8, and we use synthetic division. So we've got times, this one is negative 1 here, negative 1 gives us negative 1, add those together gives us 5, times that by negative 1 gives us negative 5, add those together gives us 8, times that by negative 1 gives us 8, gives us negative 8, which gives us 0, which is interesting because we didn't really want 0. Oh, we do want 0 because we want that number there as our, we don't want any remainders left, or we haven't actually got any factors. So now we've got 0, we know that x squared plus 5x plus 8 is the other factor. So it's this one, x plus 1 times x squared plus 5x plus 8 that we're solving. So now we've got this one, we can just use our conjugate root theorem, or we can use our quadratic formula to find the other 2 roots. So we can't find 1, we need to find both of them. B squared minus 4ac equals 25 minus 4 times 1 times 8 equals 25 minus 32 equals negative 7. So we've got our other 2 solutions as this one, x equals negative 1, that came from here, and negative b, negative 5, plus or minus the square root of negative 7 over 2a, which is 2. So our other 2 solutions are, and we need to write them as complex solutions, so they need an I, is negative 5 over 2 plus square root of 7 over 2i, and negative 5 over 2 minus square root of 7 over 2i. So that's how we would solve it. We know that these 2 are going to be, that's that conjugate root theorem, so we've ended up with our solutions. All right?